Good morning, magandang umaga po sa inyong lahat, no? Dito po sa ating bansang Pilipinas, no? Good morning, no? And to all non-Filipinos watching, there's a possibility, no, that there are non-Filipino students, no, who will watch us maybe in the near future once we uploaded this in our YouTube channel. Okay, so good day everyone. Okay, so welcome to Marinay's Powerhouse Team Review and Training Center. So my name is Engineer Reggie Marinay. I'm from the Philippines. Okay, so we have what we call this is actually a free program of our Review and Training Center. This is entitled Study Electrical Engineering the Filipino Way. No? Basically because I'm a Filipino, so maybe I am the only Filipino who will discuss the 16 subjects of electrical engineering, no? From the electrical principles to direct current circuits, alternating current circuits, up to power system, no? Up to machineries, and then up to power systems. I'll be discussing those subjects. But we have a very long time frame for this program, no? Because we will be discussing each and every topic in a very detailed way. Okay, so to our Facebook live viewers, no? Okay, so good morning everyone, no? Magandang umaga mga kawerpa, no? Magandang umaga sa inyo. Then just in case na maybe in the near future, we have non-Filipino friends who will watch this video on YouTube, please bear with us, no? The medium of instruction is in English, and then from time to time, I'll be translate it in our language in Filipino. Okay, so just a little Filipino language. It's because here in our country, we also we have what we call the Taglish language. No? The Taglish is the combination of the English and the Tagalog dialect of the Philippines. But uh, I will not discuss that way. I will not teach that way, which is in our country they call it as a Taglish. No, it's not actually a Taglish. So this is a pure English lecture first, okay, and then from time to time I'll be speaking a little of our language, no? Because well, I presume our Filipino students will also understand this. English language, no? Since kindergarten or grade 1, we use English as the medium of instruction in our country, here in the Philippines. So, welcome to our we have what we call the Restudy Electrical Engineer the Filipino Way. So again, my name is Engineer Reggie Marinay. I'm a Filipino, no? From the land of Manny Pacquiao, okay? Proud to say. Okay, and the land of Catriona Gray, okay, and Pia Wurzbach, and these are just some of our popular Filipino celebrities, okay. Uh, okay, without further ado, okay, let us start now our discussion. This is actually part 2 of the nodal analysis. I'll be solving the first, number 1 problem is actually a licensure exam. This is a board examination. To our non-Filipino friends, don't worry if I say this is a licensure exam in the Philippines. What's important is the concept. You should know the concept, how we solve the problem, whether it is from the book or whether it is given in a licensure exam. So there'll be no problem. Because basically, the licensure exam questions are found on the book also. You may find these problems in the books. Okay? So what's important is you know the principles and the concepts. Okay, let's have problem number 1. The LRT trolley system, 10 miles long, is fed by 2 substations. So basically, these are DC substations, no, that generate 600 volts and 560 volts DC. No? We mean in our country, in the Philippines, the LRT is the light railway transit. Okay? So the resistance of the trolley wire and rail return is 0.3 ohms per mile. Ohm per mile. If the car is located 4 miles from the 600 volt station draws 200 amperes from the line. How much is the current supplied by each station? So we have the following choices. Luckily, in our country, the board exam questions is in multiple choice. Okay, let us solve this problem number 1. I will draw first the circuit. Okay. I will draw the circuit. So I will have this circuit. We have two DC substations. Okay. Then we have here our load, which is our train. Okay, so this is our R sub 1, then R sub 2. Then we have the voltages, 600 volts. And then we have 560 volts. This is 560 volts. Okay? It says in our problem that the LRT trolley system 10 miles long. So this is 10 miles. From this point up to this point, that is 10 miles. Okay, the resistance of the trolley wire and rail return. So let's say this is our LRT or our train. Okay, so this is our train. So this is the rail. So ito yung release niya. No? That is the rail. And then, so we have here the trolley wire. Okay, wherein we get the supply here. Okay. Here. Okay. It's just like the principle of a bump car. Okay, in a carnival. Okay. So we have this. There is a bump car. So getting the supply from the trolley wire here. Okay. So there is a certain resistance. So let us solve our R sub 1. Okay. By the way, so it says in our problem here, the resistance of the trolley wire and rail return is 0.3 ohms per mile if the car is located 4 miles. So let's say this is the car, this is the train, that is located 4 miles. So let us put here 4 miles. Well, of course, this will be, if this is 4, this will be 6 miles. Okay? Because the total is 10 miles. Okay. So let us solve our R1. What is our R1? So our R1, so we have here 0.3. This is ohms per mile, ohm per mile, then multiplied by, so we have 4 miles. Okay? By the way, the 0.3 represents the upstream and the downstream resistance, the trolley wire and rail return. Okay, that is already the, shall we say, the loop resistance already. So that's why there's no need to multiply it by 2. Okay, so let us cancel this. Okay, so our R1 will be 1.2 ohms. Okay, what about our R2? Our R2 simply equal to 0.3 multiplied by 6 miles. So that is 1.8 ohms. Okay? Okay, did you get that? Sir Leo, nakikinig po ba? Maliwanag po ba ang dating ko sa inyo? Are you listening, everyone? So please thumbs up na.
Clear, sir. Clear po, sir.
Okay, pakita nga natin yung audience natin para nakikita ng ating mga viewers sa Facebook na tayo ay nagre-record with an audience. No? So this is a unique style. Because once you go in the watch in the YouTube, of course, the lecturer is just what do you call this? On a recording. let's say in a studio or in a classroom, so with no audience. But here we have a Zoom class, okay? So because it's still pandemic, okay? So we are on a Zoom class. Pakita mo nga, partner, nakikita na ba sila? Pakita mo. Ayan, okay. So tayo po'y live na live ngayong September 16, ha? So 9:55 a.m. Makaka-aware pa. Okay. So tuloy po natin 'to. So we will be solving this using the nodal analysis by nodal method. Nodal analysis method or nodal method by nodal method. Always remember that nodal method is based from the Kirchhoff Current Law. Okay? So, I will have here, this is current I sub 1, then this is current I sub 2. And then we have here a current. So, our car, it goes to 100 amperes. At this node, let's say this is our node A. Shall we say node A? What is the Kirchhoff Current Law equation at node A? The current entering is positive. Okay? Or shall we say, let us summarize the Kirchhoff Current Law. The current entering is equal to the current leaving. So the current entering is I sub 1 plus I sub 2. So that is equal to 200 amps. Okay? 200 amperes. And then guys, no, so let us have our voltmeter. Okay? Remember, we are using the nodal method. We always have a voltmeter, okay, that is tapped to our node, let's say at node A, and then going here. Going at our ground. So actually, this is the ground. This is our ground. Okay? So this is the positive, this is the negative. Okay? So we have the positive and negative. Take note that the given here is in amperes. Is in amperes. Okay? That is in amperes. So, just like what we have discussed in part 1, okay? So, let us have the circuit tracing. The circuit tracing, we should consider one complete loop involving always the voltmeter. So, we have here, let us disregard for the meantime our load here. So, we will be having here a one complete loop or I1. Take a look at our I1. Again, we'll be using by, again, what's this? What they call this method last time? That is the powerhouse let it flow method. That's what we call PLM in our review center. What do we mean by PLM? Powerhouse let it flow method. Now, we have here our current I1. Let it flow the way it should flow, no? Following its direction. Okay, so we have here, the current will flow on the same direction that's going to the right. Basically, it is on a clockwise direction. Take a look here. We open the load, disregard the load, and then consider this one complete loop. Okay? So, the current will flow here, the voltmeter. Okay, let's have it. Let's say this is the arrow of the current I1. Okay, take a look here. So, it will flow on a clockwise direction. Okay, what terminal of 600 volt source it leaves? It leaves on the positive terminal. Okay, the longer terminal, the positive terminal. That is why, okay, so our I1, it will be equal to what? It will be equal to what, guys? Our I1, here, positive 600. So we have here 600. Then it leaves to what terminal for the voltmeter? It leaves on the negative terminal. That's why minus B. then divided by the resistance path. What is the resistance path? This is R1. Our R1 simply 1.2 ohms. Okay? What about for I2, guys? Again, by PLM, please take a look here. By PLM, please take a look here, guys. Let's take a look here. So, we have here our I sub 2. Okay? This is our I sub 2. Let it flow here on this one complete loop. So, this loop. Okay, that's easy. So, for the 560 volts, where does I2 lives? It lives on the positive terminal of 560. So, we have here 560. And then we have to subtract V because it lives on the negative terminal of the voltmeter. And then, what is the resistance path? R2. So, our R2 is 1.8. Okay? So, that is equal to 200. Although here, we can easily shift solve using our calculator. But for the meantime, I want to show first the equation. Okay? Just like what I have teach you before. Okay. So, let us have this one. So, we have 600 by algebra. This is over 1.2. And then this is minus. Okay. This is minus V. Then over what? 1.2. Okay. And then this is plus 560. Okay. 560 then over 5.8. Then minus V over 1.8. Okay, this is 1.8. This is also 1.8 by algebra. Okay, so the negative will stay here as negative. So this is equal to 200 amperes. Okay, now guys, so please take a look. Let us have the node equation. The node equation. Okay, so please let us make our negative. Let us make this as a positive, I mean. Let's make this as positive. Okay? So, negative, negative, I will transpose. That will become positive. So, we'll be having here B over 1.2. Okay? Okay? Negative will become positive. Negative will become positive. V over 1.8. Okay. So, what else do we have here? So, the two positive sign here, this is positive, positive. Let us transpose. So, that will become negative. Okay? So, that will become negative 600 over 1.2. Okay? And then, what about this one? This one. Positive, it will become negative 560 over 1.8. Okay? So, we transpose here. So, of course, we have to put here plus. Okay? We have to put here plus 200. So, that is equal to 0. Let us simplify this. Let us simplify this. So, our V, okay, so we have here 1 over, let us factor out B, 1 over 1.2 plus 1 over 1.8, okay, and then we have here minus 600 over 1.2 minus 560 over 1.8 and then plus 200. Okay, that is equal to 0. See? Okay? Now, so take a look here. We can now calculate. This is the node equation. No? That is already the node equation. Let us shift solve that one using our calculator. Okay, make this as variable x. This is 1 over 1.2. Okay, then we have here plus 1 over 1.8. Then that is minus 600. Then over 1.2. Okay, then we have here minus 560. Then over 1.8. Then plus 200. Plus 200 and then make it as alpha calc. Then equate that to 0. Okay, and then shift calc equals. Let's wait for the answer, okay? The answer for our V simply equal to 440 volts. Okay? O, sino nakakuha sa inyo, mga kawerpa? Na-try nyo ba sa calculator nyo? Okay, so the answer is 440 volts. That is one question. What in here, what I want to show here is that the node equation here. See? This is the node equation. Just like what we discussed last time. Okay, so please take a look here. Let us connect this. Okay? This is the node equation if we have here a current. Because last time we don't have an example like this. If we have a current here. Okay? Take a look here. We have the node equation here. So, the node equation is equal to the node potential multiplied by the sum of the reciprocals of the branching resistance. Take a look here at node A. What are the branching resistance at node A? Of course, we have here R1 and R2. And we have a branching resistance here. But, there's no given resistance here. The given here is the current. This is just like you have a given current source like this. An independent current source of 200. What do I mean? You may replace this load as this current. You may replace. It's like this one. Meaning there is a current source going or leaving at a particular junction. That is leaving at a junction. Here. Remember that the 200 is leaving at a particular junction. Okay? So, leaving siya, leaving. It is leaving at a particular. So, lumabas siya dun sa junction. Take a look here at the sign convention. Take a look here. I use positive 200. Remember, the node equation is equated to 0. What I want to teach here, because in here, in this equation, you can already solve the value of B, right? You can easily solve. Dito pa lang, masosolve mo na yung B, di ba? But, I just want to teach something here. That's why I expand this, I simplify this with the node equation. What do I mean? What do I mean here? If the current is leaving, if we are following this equation, if the current is leaving, take a look. I already discussed this last time. I teach you this, up to this. But I did not teach you this last time. Naalala nyo ba yun? Did you remember? What I want to show here is the current source. If we have a current source, because on the next problems, okay, we'll be dealing with current sources. What I want to teach here is you have a positive current. If you have a current source, we can have a sign convention here. we can have a positive current. We have a positive current here if it is leaving a junction. If that is leaving a junction. Okay? What do you think if that is approaching a junction? If that is entering a junction or approaching, if it enters a certain junction, what do you think is the polarity of I? Of course, that should be negative I. Okay? So, you see this one? That is, if that is leaving, that is positive. You see, L is leaving. You see, L. You see, L. L is leaving. Leaving. You see, positive. Positive. L. Leaving. Positive. If that is leaving, that is positive. It's like a letter T. It's like a letter T. You see, L, T. L, T. If that is leaving, that's positive. That is L. Positive is like letter T. Lorna Tolentino. Lorna Tolentino. Erase mo nga yun. Ha? Yan, edit mo yan. Edit mo. Corny. O, ito na. Okay? Nakuha? Wala lang. Technical lang yon. Okay? Lorna Tolentino. Meaning, if that is leaving, that is positive. Okay? Is that useful? Lorna Tolentino? Yes. Yes. If that is entering, that is negative. You see, E negative. E negative. Oh, wala lang. Okay, that's nothing. Okay? No meaning at all. Understood to be. Okay? Again, if that is leaving, that is positive I. Always remember that this is equated to 0. Okay? Now, we already calculated for 40 volts. We just have to substitute it in here. Take a look here that I1, we have 600 minus B, then over 1.2. So, let us solve our I1 here. And what about our I2? Okay? Oh. So, we have here 600 minus 440 equals, then divided by 1.2. That is equal to 133 133.33 amperes. What about our I2? Okay? Okay, guys, this is our I sub 2. Take a look. So, we have here 560 minus 440. That is equals, then divided by 1.8. That is 66.67 ampere. See, that will be our answer. Sir, how can you check? How are you sure that you are correct? How to check? Of course, just check. That the way of checking? Edit mo yun, ha? Corny na naman. Oh, ayun, ha? Okay? So, paano mo ma-check? Of course, I1 plus I2 must be equal to 200. Okay, to check. I remember when we are in high school, in our algebra class, this is how we check. What is I1? I1, that is I1 plus I2, that's equal to 200. Well, the values are already here. Will you add this what's that? 133.33 plus 66.67. Of course, these two are equal to 200. Therefore, check na check. Okay? So, that's it. So, our answer would be letter. Okay, the answer would be letter C. Okay, mga kawerpa, nakasunod ba tayo doon? Okay? So, let's have our number 2 problem, 2 to 7. Okay, let's go with the more difficult problem here. because this is already part 2. So we have here 3 nodes, A, B, and C. So take a look. We have 3 nodes here. I will copy first the problem, 2 to 7. Actually, this problem, I already solved this, no? When we were in Maxwell's mesh method, no? So we will now solve this using the nodal analysis method. They should give the same answer. Okay. As have the given, so we have 10 here. So we have 3, 3 and 12. 12 ohms, so we have here 9 and 14. 8. We have the voltage sources. We have 200 volts, 100 volts. So we have here 50 volts. Okay, so we have here a current. I just redraw the circuit, guys. So we have here I sub 1 here. We have I sub 2. We have I sub 3. Okay. We have I sub 4. I sub 5 and 6. Okay, so we will solve this using the nodal analysis method. We have here the nodes. So we have A, B, C nodes. No? We have node A, B, and C. B sub A, B sub B, and then we can have B sub C. We can put our, we can put our voltmeter here, guys. I will make this as B sub A from here, node A, going to the ground here, which is considered to be the negative terminal. Okay? Then, I will have here our B sub B here. Okay? Then put it here. Of course, there is a positive, negative, and then we have here B sub C. See? This is positive and negative terminal. Okay? So this is our circuit. This is quite a complicated problem. Okay? So let us have the node equation at node A. No? Shall we say at node A by nodal method? Shall we say at node A. Okay, at node A, so put right away B sub A. Okay? Lagay mo kaagad B sub A. Then multiplied by the sum of the reciprocals. Okay? Take a look here, guys. Take a look. At node A, what? These are the branching resistances. So we have 1, 2, and 3. Okay? Take a look here, guys. At node A, the branching resistances are, we have here 9. I will put here 9, 1 over 9, plus here we have 1 over 3, plus this is 1 over 10. Okay? We have 1 over 10. Okay? So 1 over 9 plus 1 over 3 plus 1 over 10. And then, it says in our formula that minus. Remember, we just have to copy this. This is minus something like this one. 9 minus. So that will be the denominator, 3. And then we have here minus 10. Okay? What will be our numerator here? The series voltage. What is the series voltage? Okay? So, of 9, what is the series voltage of 9? So, we have here 200. We have 200. So, that is 200 over 9. What about the 3 here? What is the series voltage? Always involve the voltmeter. The series voltage here, we have here the 3. And then the series voltage is considered to be our voltmeter B sub B. Okay? So, put here B sub B. What about the 10 ohm resistor? The series voltage here is what? That is B sub C. You see? That is B sub C. Okay? And then that is equal to 0. That is equal to 0. Okay? Now let us simplify our equation. So we have 1 over 9. Okay, then plus 1/3 plus 1 over 10. So plus 1 over 10, that will be equal to, okay, there you, we have here our 49. This is 49. 49 over 90. So that is B sub A. Okay? Let us double check. 1 over 9 plus 1 over 3. Then we have plus 1 over 10. Okay? Okay, that's correct. 49 over 90. 49 over 90. Okay, then I will have first our B sub B. So that is minus B sub B over 3. I will have our B sub C here. So that will be minus B sub C over minus B sub C over 10. And then, we are going to transpose the 200 over 9. So please close up at this portion. So this is negative, it will become positive. That will become positive 200 over 9. So I will make this as equation number 1. Okay? Then what about our node equation at node A? At node B, I mean. At node B. Okay? What is our equation at node B? So this is our node B. Remember, there are 3 connecting resistances here. So at node B, so we have here the 12 ohm resistor is connected. Then we have the 3 ohm resistor is connected. And then we have here the 14 ohm resistor is connected. That is why, let us simply put B sub B, that is 1 over, the sum of the reciprocals, 1 over 3. Okay? Then plus, that is 1 over 12. 1 over 12, then 1 over 14. Okay? And then we have to subtract again. Let's make it 1 by 1. We have over 3 here. At node B, what is the series resistance here? Series voltage to 3 ohm resistor. So that will be B sub A. So that will be B sub A over 3. B sub A over 3. And then minus, what about the 12? In the 12. Here. Remember, we are at node B. Let us hold. Hawakan mo to. No? Let us hold first our node B. Okay, this is node B. What is the series voltage to the 12 ohm resistor? So we have the 12. The series voltage is B sub C. Always involve the voltmeter. So that is B sub C. That is our B sub C. Okay? So, what about in the 14? By the way, so we have still 14 here. So that will be minus. This is minus. Okay? So that is over 14. And then we have here 100 volts. Please close up this portion. 100 volts. Okay? Minus 100 over 14, and that will be equal to 0. Let us simplify this. Let us simplify. We have 1/3. Then plus 1 over 12. Then that is plus 1 over 14. That is equal to 41 over 84. Okay, by the way, this is 41. Okay, I will just make this as 41 over 84. 84. Let's double check. This is 1/3 plus 1 over 12 plus 1 over 14. 1 over 14. So we have here 41 over 84. Okay. I don't want to see any negativity here. Okay? I don't want to see any negative. I don't like negative thoughts. Okay? Let's be positive. I will make the negative into positive. So what will I do here is I will transpose. This is negative B sub A over 3. So I will transpose. So negative, it will become positive. See? So that is B sub A over 3. Okay, B sub A over 3. What about for B sub B? Okay, we have no choice. This is positive, it will become negative. Negative what? 41 over 84. So that is B sub B. Okay? What about for B sub C? This is negative. It will become positive. Positive. Okay? B sub C over 12. See? Negative, it will become positive. B sub C over 12. Okay, what about here? Okay, I will not transpose this anymore. So, because I already transposed B sub A, B sub B, and then B sub C, I will just stay it here. So, anyway, this is just an algebra portion. Okay? I presume that you already review our subject in algebra, so it really needs to be, we have to review, I mean, the mathematical concepts, okay, in manipulating the equations, okay, because in electrical engineering, this is already a third year subject, I remember, okay, so that is pre-assuming already that you are already finished with the mathematics subject, the basic math subjects, from algebra to calculus, okay, geometry, then calculus. Okay, so this will be our equation number 2, guys. What about our node C? At node C equation. What are the branching resistances here? So we have this 10 ohm resistor. So we have this. Remember, you have to hold point C or node C. We have the 12 ohm. Then we have here an 8 ohm. See, there is 8 ohm resistance here. That is 8 ohm. Okay, since that is at node C, right away, put B sub C. Okay? Because at node A, B sub A. At node B, B sub B. At node C, B sub C. Okay, so sulat mo kaagad yon. You write it here. Okay, what are the branching resistances? So we have here 1 over 10 plus, we have here 1 over 12 and then we have here 1 over 10, 1 over 12. What about here? 1 over 8. There you are. Here. And then you have to subtract automatically. Okay? So, for those who are just first time watching us, so because this is already part 2, please watch also the part 1 of this, no? So that you will have a good foundation. So when understanding the topic, in understanding this topic, so you have a good foundation. So again, that is minus, that is for the 10. Anyway, we can put right away all, just like what I did before. Okay. Then we can put minus, then the over. What do I mean here? Remember, it is equated to 0 here. Okay, I will put the 10 here and just copy this 10. Then we have here 12. Then we have here 8. Okay, take a look. Tingin dito mga kawer pa. Okay. Node C, what is the series voltage here for the 10 ohm resistor? Always involve the voltmeter. That is B sub A. So that is B sub A over 10. What about the 12 ohm resistor? What is the series voltage? B sub B. So therefore, B sub B over 12. B sub B. What about in the 8 ohm resistor? Who is the series voltage? The series voltage is the 50 volts. 50 volts. Okay? Now let us simplify this. Let us simplify. So please take a look first at our B sub C. So we have 1 over 10, okay, then plus 1 over 12, okay, then plus 1 over 8, that's 1 over 8. So that is equal to, okay, so we have here 37 over 120. Okay, so we have here 37. So that is over 120. Okay. Okay. I will transpose B sub A. I don't want to see any negative here. Okay? Let's be positive. Always. Okay. So, this is negative, negative. Okay? So, negative, it will become positive. So, B sub A over 10. Negative will become positive. Negative will become positive. B sub B. So, this is B sub B over 12. What about for B sub C? Okay, we have no choice here. This is positive. Positive will become negative. Okay? Positive will become negative. So, negative 37 over 120. Then, B sub C. Okay? So, I already transposed B sub A, B sub B, B sub C. I will stay is negative 50 over 8 here on the right side. So that will be our equation number 3. So we are now ready to solve. Okay, again, using our calculator, guys, no? So, mode 5, 2 in our calculator so that we can solve for B sub A, B sub B, and then B sub C here. Okay, okay. So let's have first our equation number 1 here. Okay, so we have here mode 5, 2. Okay, we have 49 over 90 equals, this is negative. Okay, so that is negative 1/3 equals, so we have here another negative 1 over 10. Okay, then we have here 200 over 9 equals, what about for equation number 2 here? We have here 1/3, positive 1/3 equals, then we have here negative 41 over 84 equals, so we have here 1 over 12 equals, then we have here negative 100 over 14 equals, okay, for equation number 3, 1 over 10 equals 1 over 12 equals, so we have here negative, that is negative 37 over 120 equals, then lastly we have negative 50 negative 50 over 8 equals, then you press now equals for B sub A. We have a value here of 133.36 volts. Okay. Then another equals 122 point, that is already 2.2 volts. Another equals for Z, we have 96.55 volts. Okay. Let us solve now for the branch currents, guys. Let's have for the branch currents. Okay, so let us have the powerhouse let it flow method. For I1, okay, we will be using the PLM by powerhouse let it flow method. Okay, for I1, what is the equation for I1? Let's have the equation for I1. Okay, please take a look here for equation of I1. Let it flow here. Take a look. Tingin ha, mga kawerpa. Tingin dito ha. Okay, let it flow here. This is our I1. Okay? Consider only one complete loop and always consider the voltmeter. So this is the one complete loop. Let it flow here. Okay? Okay? It comes out at the positive terminal of 200 volts. So that is why put here positive 200. 200. And that is, it leaves on the negative terminal of B sub A. Minus B sub A. What is the resistance path here? Anong resistor ang dinaluyan niya? 9. Okay. Let us just substitute and solve for the value. Let's have first for I1. Okay, mode 1 in your calculator. In our calculator, so we have here 200 minus B sub A. What is our B sub A? 133. 133.36 equals, then we have to divide it by 9 equals. So the answer is 7.404. 7.404 amperes. That is our I sub 1. Okay? 7.404. What letter is this? Let us show the PowerPoint here. Okay. The answer is letter B. So we are correct. Let us solve now for number 2. Okay, so that is the values. These are the values. So we have I sub 2. Okay, let's take a look at I sub 2. Always involve the voltmeter. Let it flow here. Okay? I will not, please close up. Paki-close up mabuti to. Itong portion na to. Sige pa. Maximize mo yung ano. Sige. Okay na yan. Please take a look at your monitor, guys. I will not draw. I will not draw the complete loop. I will just discuss the tracing. Okay? Consider only one complete loop and always involve the voltmeter. This is our I sub 2. This is the complete tracing, circuit tracing here. You disregard this first. Disregard this first. Okay? Do not consider, this portion. Do not consider this portion. So just consider the voltmeter B sub A and B sub B. Okay? I sub 2 will flow here. It will live on the positive terminal of B sub A. Therefore, it is B sub A. Positive B sub A. Doon siya lumabas sa positive. Then our I sub 2, it lives on the negative terminal of B sub B. So therefore, minus yon. Doon siya lumabas. I sub 2 lives on the negative terminal of B sub B. And then, what is the resistance path? It flows to what resistor? Of course, 3 ohm resistor. So we just have to substitute the values. Okay, our B sub A is 133.36. Says here minus B sub B. 122.2 equals then divided by 3. equals. So the answer here is 3.72. 3.72. Amperes. So we have here. What letter in our choices? What letter is this? Okay, nearest to letter D. Okay? You see? There's no cheating here. Okay? Walang daya, mga kawerpa. So, tingnan nyo mabuti. Okay? If you are here in our classroom or in our studio or in our power room, I have no kodiko here. Wala akong hawak na kodiko dito, mga kawerpa. No? I have no scratch paper here. I have no book here. So, it's purely on my mind. Okay. So, of course, I studied it last night. Okay. Just this morning. Okay. Okay. So, let's have now I sub 3. What is the equation for I sub 3? Take a look here, guys. This is our I sub 3. Please close up again. The I sub 3, one complete loop only. Always involve the voltmeter. So, it will flow here. Let it flow, let it flow, let it flow. Okay? Parang TV commercial. No? Let it flow. Let it flow. Let them play. Okay, let them play here. Okay? Remember that in 10 ohm resistor, we have the terminal A and terminal C. This is where the 10 ohm resistor is connected. And for terminal A, so we have here our B sub A. Then for terminal C, we have our B sub C. So therefore, what will be our equation for I sub 3? Let it flow here, let it flow here. So it lives on the positive terminal of B sub A. Therefore, positive B sub A. What about in B sub C? It lives on the negative B sub C. Okay? Negative of B sub C. So therefore, that is B sub A minus B sub C. Minus B sub C. Okay? B sub A minus B sub C. All over what? 10, of course. Okay? Let us just substitute the values. What is B sub A again? We calculated 133.36. And then we have here minus B sub C. B sub C is 96.55. That is equal. And then divided by 10 equals. SD, my answer here is 3.681. 681 amperes. Okay? That's the answer. See? Okay, let's have now I sub 4. Oh, by the way, what letter is this? For I sub 3, there you are. Okay? Oy, sakto, no? 3.681. Okay. Walang kadaya-daya, mga kawerpa, ha? Kita nyo, ha? You can also solve this at home, of course. It's up for you to verify. Okay? So, let's have now for I5. So, we have the choices. Okay, let's have now the equation for I5. O, I4 pala. I4. Take a look at I4. Okay. We have a clear loop here. We have I4 here. So, this will flow here. That will be our loop. Okay? So, it lives on the positive terminal. Doon siya lumabas. Therefore, positive B sub B minus B sub C. B sub B, okay, minus B sub C all over 12. That is equal to, okay, solve natin mga kawer pa. Ano B sub B natin? 122.2, then minus B sub C, 96.55 equals. Then divided by 12 equals. So the answer here is 2.1375. Okay, so we have 2.1375 amperes. Okay. What letter is our answer? There you are. Okay, the answer is letter A. Letter A. Okay, let's have now I5. What is our I5? Okay, take a look. Where is I5? See, there is a clear loop here. This is our I5. Please take a look in here. This is current I5. So, this is a clear loop. Okay, so pakitingnan nyo mga kawerpa. That one. Okay, this is our I5. It lives on the positive B sub C. It lives on positive B sub C. Okay? Positive B sub C, then minus, it lives on the negative of 50 volts. Minus 50. Resistance path. Of course, we have the 8 ohm resistor. What is our I5 equal? B sub C is 96.55 minus 50 equals, then divided by 8 equals S to D. Okay, my answer here is 5.1, 5.8, 81875 amperes. And that is nearest to what letter? Okay. There it goes. 5.818. That's the answer. Okay, let's solve for the last branch currents. We have I sub 6. I sub 6. Okay. So, please take a look at our I sub 6, guys. What will be our equation for I sub 6? This will be our last loop. Take a look here, guys, for our last loop. Let I sub 6 flows. Let it flows. Let it flow. Let it flow here. Take a look, guys. Take a look. That is, this branch is in parallel with B sub B. So, let us have the circuit tracing like this. Okay? That is the circuit tracing. I sub 6 is equal to positive B sub B minus 100. Okay? And then divided by 14. And that will be equal to what? What is our B sub B, by the way? B sub B is 122.22, 0.2 minus 100 equals, then divided by 14 equals S to D. So my answer here is 1.5857, 1.586. I will round up this one. Okay. So this will be our answer. Okay? Here. And that will be letter B. Okay? Sir, how sure are you that you are correct? Okay. I have doubt. Oh, you have doubt. There are so many ways to check. Okay? One way is just check your answer. Just kidding. Erase mo ulit yun, ha? Pag inedit mo. Okay. So, how to check this? At node A, I will not show this anymore because I'm doing this so many times. No? Pakita nga nung audience natin, baka tulog na tong mga to, ah. Baka, then pakita mo rin sa Facebook. Baka sa, okay, to our Zoom class participants, please open your camera before we give your certificate or else you'll be marked absent for today. Okay, so we are checking the attendance. So it depends on your attendance, your camera that should be open. So if you will not open your camera, that will be considered as you're just viewing the Facebook. Just like that one, we will not provide you with the certificate. So please open. Pakibuksan ng camera, mga kawerpa. Kasi kung hindi nyo bubuksan, sayang yung load ninyo sa Zoom, di ba? Sayang. Hindi sa Facebook na lang kayo tumingin. No, libre pa. Okay, that's for free. No? The near fact, you are in the Zoom class, this is better because you'll be receiving. Okay? You'll be receiving your certificate at the end of the course, no? After 5 years. No, I'm just joking, no? Once we finish the whole course, you will only have one certificate here. That is why we are requiring you to open your camera. Okay, sana ba tayo? Sinasabi ko. How to prove that you are correct, sir? Okay? I will disregard the way I check here. Okay, that's a joke. Supposed to be. Okay. Pray mo nga yun ng corny. Ayan ha. So, well, first of all, it is found in the choices. So, I am sure that it is correct. It is already found in the choices. That is one guarantee. Yep, you want another guaranteed? I will not show that anymore in detail because I already showed this so many times. So, please watch all my videos. Okay? So please take a look here. I will make use of the Kirchhoff Current Law. Nevertheless, I will still show you the general equation. We just need the Kirchhoff Current Law. Okay, at node A, what is the Kirchhoff Current Law? I will not write it down. Okay? The Kirchhoff Current Law, the current entering is equal to the current leaving. Okay? Okay, you write in your notebook. Come on. I sub 1, the current entering is equal to the current leaving. Yung kuryenteng papasok sa node equal sa lalabas. Okay? So what is the current entering? I sub 1, that is equal to I sub 2 plus I sub 3. Okay? We already have the value. You solve that. Okay? What about at node B? Sir, I still don't believe. Okay. What about at node B? So we have our I sub 2 here. That is equal to I sub 4 plus I sub 6. So you have to add I sub 4 and I sub 6. That should give I sub 2. Okay? Now, what about at node C? What is the equation? I sub 3, the current entering is I sub 3 plus I sub 4 because they are entering both at node C. And that is equal to the current leaving which is I5. Okay? So, that's the proof. What about here? Oh, let's say at this node. We have I5 plus I6, that should be equal to I1, right? That's the way of checking. If you still don't believe, make a Kirchhoff's voltage law here or here or here. Kung saan ka maligaya. Okay? I'm saying this from time to time because there are so many, what do you call this? Doubtful students. When I teach, this is my more than 20 years in experience in teaching in electrical engineering from different universities, in review centers also, no? And I'm also conducting lecture seminars in different universities for more than 20 years already. Okay, so let's head. Do you have any question? Okay? O, may tanong ba tayo dyan? So, tingnan natin. Baka merong tanong sila, yung ating mga Filipino audience. Sir Leo, do you have any question? May tanong ba, sir? Wala. Okay. Si Sir Ray. Sir Ray, may tanong po ba tayo? Okay. Walang tanong si Sir Ray. Si Sir Joey. Si Sir Joey. May tanong po ba tayo? Okay. Oy, Sir Elmer Mamza, no? Sir Elmer, kamusta? Pauwi ka na ba? Okay. Na-receive mo na ba yung mga libro? Pinadala ko na, sir. Yung mga libro mo, saka you have your calculator also. Pinadala ko na, sir, and also your calculator techniques book. So, I
Okay,
already...
thank you. Thank you po, sir. Dito na po sa Manila, sir.
Nandito ka na ba sa Manila, sir? Nandito ka na sa Manila?
Dito sa Sogo Avenida, sir. Baka bukas or Friday, balik na ko ng probinsya.
Okay, sa Avenida. Okay. Sige, sir. Thank you. Thank you.
Thank you po, sir.
Salamat sa pagtitiwala, no? Actually, enrollee na natin si Sir Elmer Mamsa. Tapos nag-avail pa siya ng mga libro natin, no? At saka calculator pa. Okay, sige. Thank you, Sir Elmer, ha?
You're so much welcome,
Okay,
sir.
salamat, sir. Okay, I will solve the last problem. But this is a complicated problem. This is quite a complicated problem. Okay? So please take a look here. It complicates because there is a current source. Not only one, but two current sources here. So we will solve this problem. No? You may copy the circuit. Okay, I will redraw the circuit. So you may copy. You can also draw that in your notes. Okay. I will draw first our circuit. Okay, so let's take a look here on our whiteboard. So please take a look here first. In our PowerPoint, so I just make the 2 ohm resistor here. I just make this in vertical. I made this in vertical. And also this the 4 ohm resistor, I made it as a vertical. So, well, the circuit is just the same. Okay? Will not affect any values here. Okay? So, by the way, there we forgot to put here, okay, the 10 ohm resistor. I already put here the 10 ohm resistor here. So 10 ohm yan. I put already the voltmeter. So please close up this portion. This is V sub 1 at node 1, then V sub 2, then we have V sub 3. Okay, let us have the node equation for each node. Let's say at node 1. At node 1, okay, of course, put here V1. Okay? Put here V1. At node 1, the node voltage is V1. That is P1. Okay? And then multiplied by, take a look. What are the connecting resistances? We have, okay, I will just put it here. We have the 10 ohm resistor, 1 over 10. Okay? We have the 2 ohm resistor, plus 1 over 2. Okay, 1 over 10, 1 over 2. Then we have here, again, 1 over 2. We have a 2 ohm resistor here. So we have plus 1 over 2. Okay. So again, put here subtract. You can put it like this one here. So it's a fraction. So you can put your 10 here, your 2, and your 2. Just copy this 10 to 2, 10 to 2. Then put here minus. Okay? What is the series voltage for the 10 ohm resistor? Remember, the 10 ohm resistor, we have the series voltage is V sub 3. V sub 3. What about for 2 ohm resistor here? Here. The series voltage is V sub 2. V sub 2. Okay? What about the 2 ohm here? What is the series voltage at our 2 ohm resistor here? There is no series voltage. So if there is no series voltage, automatically put here 0. Put here 0. Or basically, if you already seeing that this resistance has no series voltage, don't write it here. Okay? You may disregard this because there is no series EMF here. Well, V sub 1 is in parallel with these 2 ohms. Okay? You should not put that. That is wrong. V sub 1 over 2 because they are in parallel. Okay? It's important to note that the V3 here is in series with 10. The V2 here is in series with the 2 ohm here. Okay. This is our node equation. By the way, okay, so ito mga ka-aware pa, yung pinag-aralan natin kanina. Naalala nyo ba yung sinabi ko kanina? Lorna Tolentino. Okay? LT. If that is living, you remember this? If that is living, it is what? Positive I. Okay? Automatic, if that is entering, meaning it is what? This is positive and this is negative I. It's important to note this. It's very important. Okay, what is our 28 ampere? Is that leaving or entering? Well, it is entering at node 1. Remember, we are at node 1. At node 1, with respect to node 1, it is entering. Entering. Okay? If that is entering, that should be negative. So therefore, put here negative 28. That is equal to 0. See? Please do not mix up this to other theorem. Please. We are now on nodal. Okay? So let us simplify our equation. 1 over 10 plus 1 half plus 1 half equals. That is 11 over 10. We have 11 over 10. V sub 1. Okay? Let us review again. 1 over 10 plus 1 half plus 1 half plus 1 half. Okay? So remember, in your calculator, you can review because there is written here. So we have the final answer over here. Ito yung final answer, but there is the answer, the equation here, or the fraction. You may review. You may see in your calculator, 1 over 10 plus 1 half plus 1 half again. So that is 11 over 10, V sub 1. Okay? What about V sub 2? Here, let's take a look, guys. V sub 2, so we have here minus V sub 2, V sub 2, V sub 2 over 2. Minus V sub 2 over 2. What about V sub 3? Minus V sub 3, V sub 3 over 10. See? And then, I will make the 28, I will transpose the negative into positive. That should be positive 28. Make it as equation number 1. Okay? That is our equation number 1. Let us go over with equation at node 2, I mean. Take a look here at node 2, guys. Okay, since it is node 2, so put here V2. V2. That is the node potential. Okay, what are the branching resistances? So we have 1 over 1. Anyway, that is only 1. 1 over 1, simply 1. I'll put here 1. Okay? Because this is 1 over 1. And this is 1 over 2. Plus 1 over 5. Plus 1 over 5. Okay. Minus. Okay. So, at node 2, take note, we are at node 2, the series voltage for 1 ohm here. What is the series voltage for 1 ohm? We are at node 2. Let us hold this. We have the 1 ohm. The series voltage is our V sub 3. So therefore, V sub 3 over 1 minus V sub 3 over 1. Then another minus. We have here the 2 ohm connected at node 2. We have over 2. The series voltage is V sub 1. So therefore, minus V sub 1 over 2. V sub 1 over 2. See? Are we already done here? For 1 ohm, for 2 ohms, what about for 5 ohm? Again, take a look. At node 2, let us hold this. Hawakan mo yan. Hawakan mo to. Ito, hawak ko siya. Huwag mong bibitawan yan. Okay? Hold it. As we see here, there is no series voltage at 5 ohm resistor. There is no series voltage. So therefore, it's just 0 over 5. Do not write anymore 0 over 5. Understood to be 0. Okay? Okay, what else? No more. Okay? That is equal to 0. Okay? So, we have here, okay, our equation. I don't want to see any negative here. I will transpose the negative. I will make it positive. So, that will become negative, positive, V sub 1 over 2. Negative will become positive. By the way, for V sub 2, let us simplify. 1 plus 1 half plus 1 over 5 equals 1 plus 1 half plus 1 over 5 equals 17 over 10. This is 17 over 10. 17 over 10. I will transpose. So that is positive. That will become negative. Negative here. 17 over 10. Okay? Then we have here negative transpose positive. Oh, by the way, sorry. There should be B sub 2 here. Negative will become positive. This is just B sub 3. That is equal to 0. Okay, so this is our equation number 2. Equation number 1, then equation number 2. Then let's have now at node 3. At node 3. Here. Okay, take a look again at node 3, guys. At node 3, of course, put V sub 3. And then, what are the connecting resistances here? We have 1 over 10 plus, this is 1 over 10, this is what? 1 over 1, okay? This is 1 over 1, or just simply 1, okay? So, 1 over 10, then 1 over 1, and then 1 over 4. So, we see here 4. Then, again, put here minus. For the 10 ohm, what is the series voltage here? The series voltage for 10 ohm is V sub 1. So, therefore, that is minus, okay? V sub 1. V sub 1 over 10. Okay? For the 10 ohm, what about for 1 ohm? For 1 ohm, we have the series voltage is V sub 2 here. So, V sub 2 minus V sub 2 over 1. Okay? See here? Here. Okay? What about for 4 ohm resistor? Let's take a look here. For 4 ohm resistor, there is no series voltage. There is V sub 3, but it is a parallel voltage. You will not consider that. So, there is no series voltage in our 4 ohm resistor. So, just make it 0 over 4. They cancel out. That is just 0, I mean. Do not consider that anymore. Okay? Okay, so we have here our... Oh, by the way, what about? There is a current source here. Take a look, guys. There is a current source. We have said before that if the current is leaving, if that is leaving, that is positive. You see? Lorna Tolentino. Okay? LT, 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 Lorna Tolentino. If that is leaving, that is positive. You see? That's my technique. Even in power system, I use Lorna Tolentino. To our non-Filipino friends, no, Lorna Tolentino is one of the famous actress here in our country. Okay? The wife of the boy. The boy. Rudy Fernandez. Okay. I remember there is Rudy Fernandez who is a popular basketball player in Spain. His name is also Rudy Fernandez. Okay. Let's take a look here. Let's take a look here. Again. The 2 ampere is leaving that is leaving. It's not entering a junction. So it is leaving. So therefore, if the 2 ampere here, this is the 2 ampere, if it is leaving at node 3, if that is leaving, that is positive I. So therefore, put here positive. 2 ampere. That will be equal to 0. There you are. Now, let us simplify this equation. Okay, by the way, let us have first 1 over 10 here plus 1 plus this is 1/4. 1 over 10 plus 1 plus 1/4. That is 27 over 20. Put here 27. Okay. So 27 over 20. Okay. Over 20. Now, let us simplify this equation. Again, I don't want to see any negative here. So negative, negative, transpose, that will become positive. So that will be B sub 1 over 10. Negative will become positive. Negative will become positive. B sub 2 over 1, simply B sub 2. What about B sub 3? Positive will become negative. So that is 27 over 20. That is B sub 3. Okay? So I already transposed these 3. Positive, negative, negative, positive, positive. This positive will become negative. Then I will make it as equal to 2. See? That is our equation number 3. So we can now go to our calculator. Mode 5-2, guys. In our calculator. Again, mode 5-2. So we can get our V sub 1 here, our V sub 2 here, and our V sub 3 here. We can now calculate. Okay, guys. So what? Mode 5-2 tayo. Mode 5-2. This is equation number 1. So this is 11 over 10 equals. This is negative 1/2. 1/2 equals. This is negative 1 over 10 equals. So we have here 28. 28. Okay? Equals. We have for equation number 2 here. Take a look here. Let us input all the numerical coefficients. So we have here 1/2 equals. We have the negative 17 over 10 equals. We have positive 1 equals. So we have here 0 equals. What about for equation number 3? 1 over 10 equals. We have here for B sub 2 simply 1 equals. For B sub 3, so we have here negative 27 over 20. Negative 27 over 20 equals. Okay? Then we have here 2 equals. Okay? So that is 2 equals. Okay? So, put here equals. There it goes. So we have our V sub 1, that is 36 volts. V sub 2 is 20 volts. Then V sub 3 is 16 volts. These are the values of the voltages. Now, you may verify that in your seats there. You can verify, guys. Huh? Okay, so let us have now the branch currents. Let us have the branch currents, guys. Where will I put that? So I will just put it in here. I will put it in here. Okay. Okay, I will erase this. We are finished here. Okay. I will use the space here. So what is our I sub 1 equation? Okay, guys. Tingin ha. Powerhouse let it flow method. One complete loop only. One complete loop only. What do we have here? Remember, this is our I sub 1. Please close up this portion. Please close up this portion. This portion. So we have, okay, take a look. Tingin dito mga kawerpa. Ito yung complete loop natin. Yun. Okay? So it lives on what terminal? This is one complete loop. That is positive B sub 1. It is positive B sub 1. So put here B sub 1. Okay? And then, over what? Over 2. Over 2. Anyway, it's just Ohm's law, right? What is our I sub 1 equal to? So, our B sub 1 is 36. So, that 36 divided by, you see, I'm not good in mathematics. B sub 1, 36 divided by 2. Of course, that's 18. We can disregard our calculator, no? But still, I'm using it. I want to be sure. Okay. You see? You can be an electrical engineer, even though you are not great in mathematics. Me, I do not consider myself great in mathematics, no? Many people said that, you will take up engineering, you should be great or you should be very good. You should be excellent in mathematics. I disagree. Again, I disagree. Okay? Because you need your calculator. There is calculator. Let the calculator do it for you. Okay? We are lucky. No? I don't know in the other country. Well, I think so. No? Calculator, if in their licensure exam, no, or state board, in our country, we call this as board examination. No? This is state board. No? In America, in the US, I think they have this, what we call the engineer in training or the professional engineers exam. No? Calculator is also allowed. Okay, so in our country, this is a very, very useful calculator. Then we have the latest from Casio, which is allowed. No? So this is the 570 ES Plus. This is the second edition. No? So baka may gustong umorder. Anyway, I'll just have it next later. Okay. What I'm saying is you don't have to be great in mathematics. What's important is you love math. Just love mathematics. Okay? I disagree with this. Again, I want to show this with you for the first timer. I saw in a t-shirt, math. What is the meaning of math? Mental abuse to humanity. Is it true? I disagree. Okay? It's not true. We all love mathematics. Especially during the 15th and 30th of the month. Because that is the payroll. That is the salary. Okay. So, what is our I sub 2, guys? Oh, by the way, I have to show my PowerPoint. Our answer on the board is 18 ampere. Okay. I just thought we are finished already, but we are not yet. Okay. So, the answer, okay, is 18. See? It becomes color red. Again. So that you will see it. Okay. Ulit ito. 18. Okay. There you are. Okay. Nakita ba mga kawerpa? Ayan yung animation natin. Kita naman. Okay. Kitang-kita naman. Okay. Let's have it for I sub 2. Here. Take a look again. Let us have the I sub 2 equation. I sub 2 equation here. Okay. So let's make it a little advanced, no? Because this is this topic. Next meeting, we'll go now to, I think the superposition theorem is our next topic for next meeting. Please take a look here. I sub 2, we have one complete loop here. Always involve the voltmeter. Always involve the voltmeter, please. This is our I sub 2. We will consider voltmeter 1 and voltmeter 2. Again, this is one complete loop. I will trace this for you guys. This is our I sub 2. And you see? You see that? Hirap kumita. You see? Here. Okay, nakita? Nakita nyo ba? So, we have here I sub 2. Our I sub 2, it will live on the positive terminal of B sub 1. Therefore, put here B sub 1. Okay? For B sub 2, this will live on the negative of B sub 2. That's why put here minus B sub 2. And then what about the resistance path here? That is the 2 ohm resistor. Put here 2 ohm. Okay. Let us substitute, then calculate. Okay. Okay, what is B sub 1? 36 minus B sub 2. B sub 2 is 20. Okay, 20 equals. Okay, divided by 2. That's equal to 8 ampere. Oh, yan ang sagot. 8 ampere. Anong letter ang sagot natin? Anong letter ang sagot natin? Ito ay letter. Okay. Letter A. Nakakuha ba? Nakasunod ba tayo? Okay. Tuloy natin. You see, mga kawerpa, nakita ba? Okay, 8 ampere, walang daya, mga kawerpa. Nakita nyo, Okay? So, we have here our I sub 3. Okay. Kuhanin natin ang I sub 3. Hirap kumita, partner. Okay. So, ito. Sabi ko kasi, tatagalogin ko na lang. Gusto ni Bossing, Englishin daw. Okay, so ito Oh. Please take a look here, guys. Please take a look here. I sub 3, where is the circuit tracing? Of course, the 10 ohm is connected to node 1 and node 3. It will flow here, one complete loop. Let us always involve the voltmeter here. Always involve the voltmeter. One complete loop only, one complete loop only, one complete loop. Okay? You see this one? Okay, tingnan mo mabuti yung I sub 3. It lives on what terminal? The 2 voltmeter involving I sub 3 is V1 and V sub 3. Then the I sub 3, it will live on the positive of B sub 1. Okay, so put here positive B sub 1. Okay? Here, it will live on the positive of B sub 1. What about for B sub 3? It will live on negative B sub 3. Okay? So that is minus B sub 3. What is the resistance path? We have the 10 ohms. So put here 10. So that will be equal to what? Now, okay, let us solve. So we have B sub 1, that is 36, then minus B sub 3. B sub 3 is 16. That will be equal to 20, then divided by 10. Of course, the answer is 2 amperes. Okay, what letter is this for our I sub 3? Okay, that is I sub 3 for number 10. The 2 amperes is, yes, that's correct. Okay. Letter B, ang sagot natin. Okay, punta naman tayo sa I4. Ano equation sa I4? Oh, tingin mabuti. Oh, this is our I sub 4. Remember that I sub 4 is the current flowing through the 1 ohm resistor. And the circuit to be considered is this circuit. As you see here, this is the complete loop. Okay. This is our I4. It will flow here. that is leaving to the positive terminal of B sub 2. I will make it positive B sub 2. Okay. B sub 2. Okay. Positive B sub 2. It leaves on the positive of B sub 2. Then minus B sub 3. Okay? Minus B sub 3. And then divided by 1 ohm. Okay? What is B sub 2 minus B sub 3? Oh, anyway, I will not use my calculator. This is just 20 minus 16. Oh, that's 4. Okay, very easy. Okay. So, 4 ampere. Okay, that is for number 11. Let's take a look, guys. Okay, that is 4 amperes. That is letter D. You see, it becomes color red. Okay, let's go now to number 12. Our number 12 is our I5. Oh, tingin, mga ka-wear pa, ha? Tingin dito, mga ka-wear pa. Okay. This is our I5. Remember, I'll give you a little technique. Please close up this portion. Our I5, there is no series voltage in here. But there is a parallel voltage. Who is parallel voltage here? Of course, no other than V sub 2. If that is just simply parallel, that is only Ohm's law. So that is V sub 2 over 5. Okay? Ohm's law. Huh? So what is our V sub 2 here? V sub 2 is 20 over 5. Okay, no need for calculator. See, I don't have calculator here. Okay. Okay, nakuha ba mga ka-wear-pa? Nakasunod naman tayo dyan. Okay, I6 tayo. This, the last current. Okay, for I5, what number? What letter? For ampere, you see letter D also. But there's no PowerPoint for I6 here. There is no PowerPoint. There's no PowerPoint for I6. Anyway, I'll just show this one to you guys for I sub 6. Sorry, there's no PowerPoint. It was deleted. Okay, so, here, hindi ko na isama sa paste. No? Hindi ko na isama. Okay, anyway, please take a look here for I6 because this is very easy. Take a look here. This is our I sub 6. Okay, just like I sub 5 before, I sub 6, there's no series voltage here. But there is a parallel voltage, which is our B sub 3. So our I6 simply equal to B sub 3 over 4. The parallel voltage to 4 ohm is B sub 3. So make it as B sub 3. B sub 3 over 4. B sub 3 over 4. Yan. O, ano ba yung B sub 3 natin? Okay? So our B sub 3 is 16, then divided by 4. B sub 3 is 16. Of course, that's 4. I use my calculator. Okay. So, you see, I remember my professor, in the board examination, even 2 plus 5, you will use your calcu. Well, that's a negative effect of depending always on the calculator. But it's reality. That is reality. See? So anyway, for I6, that's also 4 amperes. No? So we have here our I sub 6 here. Okay. So we have our 6 here. I sub 6 parallel. B sub 3. So our B sub 3 is 16. Okay. 16 volts over 4. So that is 4 amperes. Okay. So well, that is our lesson for today. Okay. That ends the nodal analysis part 2. Okay? So next meeting we'll go to superposition theorem, guys, no? Punta tayo sa superposition theorem. Okay? So I hope you learn. So may I see our audience first? Patingin nga nung ating mga Zoom class participants. May I see if you have any questions, no? Or if you don't have any, so please give your comment if you have. So please give your comment or anything you want to say regarding our program here. Okay? Please speak in English. Sir Leo. Hello, Sir Leo. Can malis ka na yata ah. Naglalakad na si Sir Leo. Si Sir ano na lang, si Sir Joey. Sir Joey. Oh, may ano yan. Ayan, yun. Sir Joey, any question? Do you have any question first? Oh, nawala na yung ano, yung isa, yung babae nawala.
Sir,
Okay.
good morning.
Yes, sir.
Actually, I have no question, sir, but I have some inputs.
Yes. What about?
Sir, every time I had an opportunity to join in your lecture, I will do it. I am
Please
not
speak
against,
louder, sir. Please speak louder. I can't hear you.
sir.
Please. Okay.
I am not against the certificate, but the knowledge I have learned, I gain every time I join this kind of free lectures from you, step by step, the way you teach us and discuss the lectures clearly, a very detailed way, and it is easily to understand. It is a big help for us as we prepare ourselves for upcoming board exams in the future. Again, thank you very much. More power, because the power is in the house.
Oh,
God bless.
thank you very much. Thank you. Thank you for the
Thank you.
let's give him a hand, no? Okay. So, thank you for that compliment, Sir Joey. Okay. I remember my student. Oh, he was a board nature. He got top 5 in the registered electrical engineer licensure examination. When he put his comment on the way I am teaching, because since third year he was my student, he always gave this comment with me. If you when you solve problems, sir, it's really different from my other professor, because in my other professor, although they are board top notchers or they are with masteral degree, doctorate degree, but I don't understand the way they teach, because they teach too fast or they teach right away the shortcut, but I don't know the principle. But you, sir, when you teach us first the principle, then you explain it in a very detailed manner. Parang ang pang grade 1, sir, eh. Sabi nga nung ano, sabi nung estudyante kong nag-top 5 sa REE board, sabi, alam mo, sir, ano na lang eh, yung hindi makakaintindi sa'yo, parang mahina na lang ang ulo nun, sir. Parang he used the term, bobo na lang yun, sir. Ayoko sanang sabihin, no? Alam mo, sir, bobo na lang yung makakaintindi sa'yo, eh, sabi nung aking estudyante. Kasi pag nagturo ka talagang detalyado, hindi maintindihan. Eh. Tingin ko kahit high school graduate, maintindihan ka, sir. Yung mga kasama ko nga dito, high school grad, pero nakakasunod eh. Pwede na nga mag-solve ito ng ano eh. Pwede na nga mag-aral ng electrical engineering yung mga kasama ko rito sa studio eh. So, no? Sabi nga nung aking estudyanteng board top notcher, he said that when you solve really, it's so easy to understood, sir, to understand. I read a book, I don't understand the book because first that is in English. The explanation is too long, but it took around 2 to 3 pages for the explanation of nodal analysis. It's so many pages. Pero ganun lang pala yun, sir. It really looks easy when you are the one solving on the board. What are you eating, sir? Ano ba kinakain mo, sir? Sabi sa akin. Well, that's a compliment. It's just that what's important is we have the heart to teach. Okay, we have the heart to share. Yung iba kasi, pinabili lang ng suka, teacher na eh. So, bakit ka nagtuturo? Why are you teaching? Sir, because I can't find a job now. I just recently passed the board examination. I can't find a job. Oh, really? I'm thinking that, is that teaching? If you don't have a job, if you're looking for a job, ganun ba ang pagtuturo? Pag wala kang makitang trabaho, if you didn't if you don't see any job, then you will settle for teaching profession. Should not be the case. The teaching profession must be in your heart. I give a lot of pride. I have the highest pride with this profession. No? In terms of my job, my work. So I have the highest pride. So isa ako sa makikilala yung pinakamataas ang pride sa pagkilala sa teaching profession. And I really prepared for it, and up to now, I'm preparing, I'm studying, even though I'm already teaching for more than 20 years. No? Many people would say, you already mastered the subject. No, it's not. It really needs a lot of sleepless nights, or a little sleep, maybe 2 to 3 hours. No? And I remember when I teach in my first year in engineering, I even practice in front of the mirror, you see, just to see myself. I remember my first year in teaching, because this is my passion. And one of our purpose in doing this pre-lecture is we believe that many electrical students, sad to say this, were not being taught properly by their professors. Because there are professors that he teaches too fast because he is a board placer. He presumes that his student know that already. O, bahala na kayo. Malaki na kayo. Okay? I am not that kind of teacher. Well, good for you. You are an intelligent student. Good for you. If my way of teaching is a spoon-feeding style, this is how I teach in the review. I made this as a very long process or time frame for electrical engineering. Because in the review, sometimes we have no choice but to teach in a faster way. That's why I decided to have this, so that whether you enroll to us or not, just take a look at my videos on YouTube, then I already help you. When you enrolled, like Sir Mamsa, Sir Elmer, when I teach electrical engineering subject in the review, of course, that will just be an additional, because this is already a jam pack. But I don't know when will this be finished. So, because we are really planning to discuss the most detailed way in studying almost all electrical engineering subjects. We have here, these are the subjects that I will teach you. DC circuits, electrical transients, DC machineries, transformer, alternator, induction motor, synchronous motor, converters and rectifiers, electrical equipments, illumination or lighting, power plant engineering, power factor correction, and power systems. I will discuss all of these subjects, but when I will finish these subjects? I am just on topic number 2. Okay? So this is a book. We call this in Spain as obra maestra. This is my obra maestra. Okay? No one knows. No one knows. So this is my obra maestra. This is my part, my share to all electrical, engineering, or technology student. Because education is too expensive. There is one comment. Sir, is there any, I have a friend who are civil engineering. Is there any review center like you giving free webinar, free lecture? Because the review in our course is very expensive. Is there any review center like you in civil engineering? There is none. So, if you are an electrical student or graduates, maybe you are quite lucky to meet us, because we really work hard. This is not being boastful, no. We really work hard. because we really want to do our share. We started giving free lecture on air or in YouTube or Facebook since June of this year, when, of course, with the advent of pandemic, no, we are experiencing right now. So me and my partners think of how we can help you. We have we don't have a lot of money. This is our little share. We consider this as a little share. Many students said, this is a big help for us, sir. No? For us, it's just a little share. For you and your family. Okay? So, well, thank you for the compliment. No? Maraming salamat sa inyo, mga kawerpa. So, tama na. Baka maiyak pa ako rito eh. So, ayun lang po ang aming masasabi. So, sige, si Sir Elmer. Sir Elmer, can I get some feed from you? Any comment?
Good morning, sir.
Yes, good morning, sir. Speak in English, ha?
Actually, sir, I appreciate and thank you so much for your time and effort. I know you are a kind heart to support some professional and industry worker like me, because this good condition and principles eventually in the actual works, like to say in the previous before na
Pakita natin sila.
experience is a good education, but for me and at you say in the previous before, in a good education is a good foundation in principle, so that it could apply in the actual works, so that
Okay.
in the future to become a good specialist. You will not a good specialist in the troubleshooting or actual installation if you will not know the principle and the theory in the electrical engineering. So I acquired some industry worker that it is a good opportunity like this. They have an online review. Thank you so much, sir, and thank you for this opportunity.
Well, thank you, thank you. Sir Elmer, are you working in abroad in the Middle East?
Actually, sir, my work experience is in different country, mostly in the Africa. First in the
Did
New
you work in the
Caledonia.
Middle East?
No, sir, in the part Africa, sir.
In Africa. Okay.
Africa and New Caledonia.
Okay. Because you still have the African accent when you speak the language. Okay. So thank you, sir.
Thank you so much, sir.
Thank you. Salamat, sir, ha. Thank you, thank you.
Okay, you're welcome,
Sir
sir.
Leo, nagdadrive ka pala dyan, ha. Ingat ka dyan. Baka mabunggo ka. Ingat ka, ha. God bless you, ha. Okay. Thank you, Sir Elmer. God bless.
Okay, God bless you, sir.
Can I hear to is she a first timer? What's her name? From TUP Taguig? Ano pangalan niya? Jonabel? Okay, paki-spotlight mo nga si Jonabel. Ano natin? Jonabel, can I hear from you? Do you have any question or comment in our what we are doing right now?
Wala naman po, sir. Thank you
Speak
po.
in English. I can't understand.
I have no question, sir. Thank you for teaching. This
What?
is just, we have tackled this lecture when I was first year college and I am in second year. I am reviewing right now because I don't have class.
Okay. How would you compare this lecture to before?
I
When
compare
you were in
this,
first year, you said you tackled this already when you were in
yes,
first year.
yes po.
How would you compare?
I compare your teaching strategy is so step by step and I like that po. Thank you po.
Okay. Thank you. Thank you. Ano pangalan ulit? Jonabel, no? Uh, intelligent student may not like my system. Intelligent student in the Philippines. Because intelligent student, they want always shortcut right away. Sad to say, many intelligent students like that because I already, in my more than 20 years in teaching, many intelligent students, they find it boring when I explain in a detailed manner because they believe they'll become board top-notcher. When they took the board, they did not become top-notcher. Too boastful. See, always have our feet on the ground. No? We always teach our student to become humble, to be humane, or what do you call this? Be passionate on it. Be humble. No? Okay? So mahirap 'yon. Mahirap pagka feeling mo alam mo na lahat, no? Because I already experience having a student. Actually, I teach in the leading review centers in our country. They know me. They know me. Kilala nila ako. No? Kilala nila ako. Okay. So, I teach with them. During the time, they produce top-notchers, even top 1. I'm there as one of their teachers. Maybe I help their top-notcher. It's because I'm one of the teachers. See? I'm quite sad to those students that I will not enroll with Powerhouse. I don't like their idea of spoon feeding. I want a shortcut right away because I'm a great student. See? Too boastful. But I met a lot of humble students. Many board top-notchers are humble students. Those boastful students, many of them, majority of them did not top the board. I know that because for my 20 years, this is my life already. A solid more than 20 years. That was 1998. Anong taon tayo ngayon? 22 years. I do not consider myself 22 years in teaching because even when I was in high school, I am teaching. Yes, when I was a high school student, I am teaching. Why? Because when my teacher is absent, Reggie, you teach your classmate this topic. Ha? No, alam ko dyan, ma'am. Aralin mo na lang. Bahala ka na. It happened, well, quite a number of meetings. If my teacher is absent because she was pregnant, manganganak na ako. Ikaw muna dyan. Pero may kasama naman ako. Isa ko pang kaklase na mas magaling sa akin sa math yun. Hindi naman ako magaling. Ano lang ako? Enthusiast lang ako. No? Enthusiast lang ako. I don't consider myself as an expert. Kaya hindi tayo ini-enrollan. Kailangan yata sabihin natin, expert kami. No? Mahirap yung ganun eh. Yun naman ang reality. Hindi naman tayo talaga expert. No? Kahit naman pinakamagaling ka pa tingin ko hindi ka naman expert. Tingin mo lang sa sarili mo yon. So, okay. So, let us discuss this, no? This is a continuous pre-rest study of electrical engineering. For the month of October, so please bear with us. Maybe we will adjust the schedule of this. Baka i-adjust namin, no? So, anyway, we will keep you updated, no? So, we have a pre for the non-electrical engineering courses who are watching us right now sa ating Facebook. So, we have a free Master Electrician Fundamental course. This is every Sunday, 9 a.m. to 12:30 p.m. Philippine time. O yan, mga master ha, inaanyayaan ko kayo. No, baka available kayo sa ating pong mga pag-aaral, no, ng electrical engineering o ng master electrician also. Okay, first come first serve basis po tayo ha. First come first serve basis. Ibig sabihin, pasok kayo kaagad sa Zoom natin. Okay? So, to our non-Filipino friends, so I have a YouTube channel. We already downloaded more than 70 videos, no? some of the videos here were, these are actually a paid lecture before. Now we'll just give it free for everyone. Okay? This is our help. One way of helping you guys, no? Although what I can say is, of course, we did not uploaded all the lecture videos that we have. No, no, that's already on our part of our business. No? If you want to know everything, experience more our review system, so you may enroll to us. Okay. So we have here our my YouTube channel. This is the official YouTube channel of MPHT Review Center, the Marinais Powerhouse Team Review and Training Center. Okay, so please subscribe, like, and share. Please share this to your friends, to your classmates, no, to your workmates, no, to your even to your enemies, no. So you may share this. Okay, study electrical engineering the Filipino way, no. I say this, I really mean this, no, because when you are looking for a certain topic in electrical engineering, there are so many Americans, many Indians, no, giving lecture in electrical engineering, no? Para naman maiba, magkaroon naman ng Pilipino na nagle-lecture ng electrical engineering, no? Kasi bihira lang yung mga Pilipino nagle-lecture ng electrical engineering. Meron, konti-konti lang, no? May nakita naman ako, kaya lang tinataglish nila, hindi nila pure English. So we have some Filipino friends who are giving lecture, but it's not in pure English. So, and I think their target market is only the Filipino students. But we want to target the people around the globe, no? So that's why we are. I'm sorry, no. I don't have an English tongue. Okay, so sometimes I have a wrong grammar, so I apologize, no. Pero sabi nga nila, even Americans sometimes they have wrong grammar. So that's what English teacher said to me. So I'm sorry that sometimes I don't have a correct grammar, no. So I'm sorry about it, no. I am not that proficient in speaking the language, but I'm trying hard for everyone to understand this lecture. Okay, don't worry, I will study online. I will improve myself in speaking the language. Okay. So we have here, Study Electrical Engineering the Filipino Way. That is my YouTube channel. Okay. So, meron pa mga kawer pa. Diretsuhin na natin to. Okay? Kasi maraming nanonood sa atin. No? To our non-Filipino friends, so please bear with us. Okay? So, just a few minutes. So, we have the pre-webinar for September. Okay, may natitira pa po tayo, no? Bukas, meron tayong pre-webinar. Ila-live ko to, taglish. Okay? Tataglisin ko to. Magandang topic about motor protection. I'll be discussing different types of overload relays. Their functions, their parts, their operating principles, and applications. I'll be discussing that. Actually, for the month of October, there are still part 4 of motor protection. Even, I think, part 5. So this is a very long discussion about protections. I will touch power system protection, different parts. Okay? And then, topic number 7 here is the short circuit and lighting design for high-rise building. Ito, dati to may bayad to, ha, mga kawer pa. Ngayon, libre na lang namin ibibigay sa inyo, no? Okay? Then, we have the power system harmonics. That will be our last topic for the month of September. So just wait for our October 2020 topics. Okay? So we have we will give right away, right after the webinar, we'll give right away the free e-certificate for each topic. You may attend all topics for free. Kasi may nagtatanong pa eh, Sir, kahit ilan ba pwede yan, libre? Oo, kahit maging 100 mahigit yan na topic, no? So, balak na namin magbigay ng webinar, siguro mga konti lang, mga 1,001 seminar. No? Hanggat tayo may buhay at lakas, di ba? Pinagkakaloob ang Panginoon sa atin. So, tuloy-tuloy po ito. Di namin alam kung kailan matatapos itong aming activities, no? So, feeling ko, wala pa po kami sa 0.00001% ng aming gustong ibigay sa inyong lahat, no? Wala pa po. Okay, sige. So, then meron din po tayong special webinar. Ay, siya nga pala mga kawerpa, no, sa ating mga viewers sa ating Facebook Live, no, meron po kaming special webinar na bubuksan this Saturday. Ito po yung Practical Electrical Estimation Course. Baka gusto nyo pong umattend September 19 and 26, 9 to 12:30 p.m. No? So 9 a.m. hanggang 12:30. Magkano yan, sir? 1,500. Murang-mura, mga kawerpa. No? But wait, there's more. If you are electrical student, engineering man o technology, 70% discount. Meaning, 450 pesos na lang ang babayaran mo sa ating practical electrical design. Isa to sa pinakamaganda, pinaka-useful na topics. No, kasi practical ito. No, given electrical plan, paano ka magku-quantify? How many boxes of wires, no? How many lengths of conduit, okay? How many junction box, utility box, how many elbows are you going to use? How many couplings? So, everything we will estimate. Okay? So, this is a very good idea. I think this were not being, because there are already an engineer attended to my lecture here. Sir, this was not discussed by my professor. That's why I attended your lecture. Hindi naman yan tinuro sa amin nung college kami. So, I will teach you the practical way of estimation course. Okay? Then, we had the practical electrical design course. Well, anyway, next month pa po yung next batch niyan. Siya nga pala sa Sunday naman, mga kawerpa, September 20 and 27, 9 to 12:30 p.m. pa rin. So, yung fee natin is 1.5 para sa motor control, industrial motor control. Live lecture po itong dalawang to. Yung estimation and motor control course. No? Live lecture ko po yan. Baka gusto nyo pong umaten, mga kawerpa, murang-mura lang rin, 1.5 lang. Ayan po ang pinakamurang training o webinar ng motor control. So, wala pa po tayo kasing face-to-face, no? Pero meron po kaming ginawang mga simulations so that makita man nyo siya sa actual, hindi kayo mahirapan magkabit-kabit, no, ng mga devices ng motor control. Again, for the student, it's only 450 pesos. No, napakamura, inaanyayahan kita, Jonabel, no? Inaanyayahan kita mag-attend, no, nung ating special webinar na ito. Actually po, sa loob ng isang buwan, lagi po kami magko-conduct nito. This coming October, we will have it in the afternoon, up to evening, from 5:30 p.m. to 9:30. 5:30 to 9:30 p.m. Iko-conduct po namin itong mga special webinar na to. So, just keep updated, no? We'll keep you updated, no? With our, we will post that in our Facebook account, no? Well, this is our Facebook account, the Marinais Powerhouse Facebook account. And my YouTube channel is Reggie Marinay YouTube channel. Okay? So, we'll be giving you these 5 topics per month. Building wiring installation, industrial motor control, practical electrical estimation course, practical electrical design course, with the power system or high voltage engineering. So these are the course outline. No? If you have any question about the outline. Okay. So ito po yung ating mga course outline, mga kawerpa. Makikita nyo po. Okay, so for motor control, this is our course outline. Okay. Kasi may mga nagtatanong ano daw yung mga topics na i-discuss, what are the topics. So, from the switches, breaker, relay, magnetic contactors, okay, Y delta up to Y delta starter. Then I will have a lecture on variable frequency drive and an introduction to programmable logic controller. No? So we'll give you that topic, no, for a very low price. Okay? Then this is the practical electrical estimation course. No? I'll be discussing the materials take-off, the material costing, labor costing, preparation of the estimate, bill of materials, preparation of total offer price for your proposal. Okay? So we have the practical electrical design, residential, commercial, industrial, and high-rise building design. For the power system engineering, I'll start it with the inductance, capacitance, then short, medium line, up to protective relaying and load flow analysis. I will discuss it with you guys. And then we have the early bird promo of our REE review. So ang early bird promo namin, mga kawerpa, 10,000 lang po. Review, refresher na for REE. Kung kaya nyo pong i-cash. Ang deadline po namin, nag-extend na po kami niyan hanggang 17 lang po, mga kawerpa. Tama ba? Hanggang bukas na lang pala ito. Baka gusto nyo humabol, mga kawerpa. No, 10,000 lang po ang aming online review. Maganda naman online, no? Makita nyo naman, no? Pinapatikim na namin kayo. Matinding patikim na nga itong ginagawa natin, no? Ganito po, this is how we will conduct the review program, no? And also we have some recorded lectures din na ipapakita sa inyo. Okay, so mga quality lectures po ang inyong ma-experience sa Powerhouse, no? Experience the virtual classroom at the comfort of your home. So marami pong mga freebies kaming ibibigay. We have the free lecture handout, no? Yung mga soft copies niyan. Take home exam with solution. Even free board exam. Dati may bayad pa sa atin to. Ngayon, lilibre na namin. May solution na rin yon. And then we have free e-certificate, no? Okay? So, ayan po. The best online review setup among others. There, no? We are there to compare. I-compare nyo po kami, no? Okay? So, yung iba naman, kung kayo'y mag-enroll po sa iba, tanungin nyo po sana ng detalye kung paano po yung sistema nila sa review. Kung yun po ay talagang matututo kayo, so why not? No, nasa inyo naman po yan. Hindi naman namin kayo siyempre mapipilit na kayo'y mag-enroll po sa amin. But we can assure you this, all of this, we are doing all of this. We guarantee the high quality teaching, review materials, and as a whole, the review program, we will guarantee you. Okay, for REE, sabi natin 10,000, no? Kung ika-cash mo siya hanggang bukas. For Master Electrician, 9,000 lang. No? For Master Plumber, meron din po tayo, mga kawerpa. 8,000 lang po ang cash. Hanggang bukas na lang po ito, mga kawerpa. No? Yung ating mga viewers sa Facebook natin, baka gusto nyo po mag-avail ng aming review program for April 2021, REE RNT Board. Master Plumber, February po ang board exam niyan. No? Eh sir, wala akong pang-cash. Pwede ba sir installment? Pwede po, mga kawerpa. Pwede. Kaya lang po, madadagdagan po yung inyong fee. No? Pero maganda rito, kahit mag-down ka muna ng 2,500 hanggang bukas lang po, yung 2,500, then yung balance mo, babayaran mo sa first day of the class. No? Ang REE po, magsisimula sa November 7 at saka January 4, yung isang section namin. No? Halimbawa, REE magiging 12,000 po. Madadagdagan po siya ng 2,000 pesos, mga kawerta. Magiging 12,000. So magbayad lang po kayo ng 2,500 bukas, and then yung balance yung 9,500, that will be on the first day. Doon nyo po ipupulfill, ikukumpletuhin niya. No? Sa RNE naman po natin, yung 9,000 magiging 11,000, mga kawerpa. So yung 2,500, babayaran po hanggang bukas. Then yung balance po natin na, ano yun? 8,500. Yung 8,500 po sa November 29, no? Which is start natin. Ang Master Plumber po, 10,000 na magiging installment yan. October 4. Maagang start po namin sa Master Plumber, mga kawerpa, kasi po ay meron pa pong hanggang February lang po kasi ang board exam niya. No? No? October 4. I-schedule po namin yan. Okay, may ano po yan. Okay? 11 pala, mali pala ako. 11, okay? 11 po yan, no? Hindi mo sinabi sa akin. So, 11 po, 11. Okay. Sige po, mga kawerpa. So, ito po ay 100% discount on second online review course when you fail the board exam. Ano ibig sabihin? Mga kawerpa, pagka po kayo bumagsak sa board, wag naman sana, ha? This is just an insurance. May insurance kami sa inyo. Okay? Dapat nga maisip nyo na na talagang we are serious, no? Ay, pagka sumabit kayo, yung next review course ninyo, libre na kayo. Okay, mga kawerpa, so free na po yung inyong review course sa next batch, no? Okay? Wherein yung babayaran nyo po ngayon yung promo namin, promo lang po ito mga kawerpa, I suggest i-avail nyo na po habang maaga pa. No? Kasi po, habang tumatagal, nadadagdagan po yung presyo niyan mga kawerpa. No? Sayang po yung malaking discount na makukuha nyo po. Okay. Up to 50% discount pa naman yan. Pero po ito mga kawerpa. Computation set 1, set 2. Computations din, may mga objective type tayo. Okay? And then yung mga electrical theories ng Math SSEE. Okay, this is for 3,600 mga kawerpa. No, meron kaming promo magsisimula po today. Anong day today? September 16. Magsisimula actually no isang araw pa pinromo na natin eh. Mula September 14 po hanggang maubos itong aming ipapalibreng libro na ito. Pag bumili po kayo niyan ng 4 na libro, may libre pa po kayo nito. But wait, there's more. Free shipping pa po ito kahit sa probinsya. Another promo pa po yun. Kahit sa Mindanao pa yan, ililibre po namin ang shipping nito. Basta sa Pilipinas lang, ha? Okay. Free shipping. Rinig ako, ha? Okay. So, murang-mura mga kawerpa, no? May libre na po nito. Alam nyo, itong libro pa lang po na to, maabot po ito ng more than 300 pesos. So, ililibre na po natin. Plus, yung shipping fee, minsan it costs 200 plus to 300, 400 pesos. Ililibre na rin po natin yon mga kawerpa. No? So, sa mga gusto pong mag-avail, sa ating mga kaibigan sa Facebook Live na nakikinig, so baka gusto nyo pong umorder, how to order, sir? So, mag-send lang po kayo, mag-PM lang kayo sa Marinais Powerhouse Messenger account. O sa Facebook po namin. No? Ayan. So, maganda, diretso nyo na po sa FB, sa Messenger po namin. Okay, so 3,600 po yung 4 na iyan. Okay? Meron din naman po tayo mga kawerpa ng Master Electrician. 2,600 po yung 4 na yan. Technical, PEC topic. No? We have the Journeyman and Master Electrician by Tom Henry. So, ayan po. 4 na libro po worth 2,600 pesos. For the Master Plumber, we have 4 original books, no, except the plumbing code. Of course, code kasi yan. Then the plumbing utilities. The Plumbing Arithmetic and the Practical Problem and Sanitation and Plumbing Design are original books of Powerhouse. Okay? So baka may gusto po sa inyong mag-avail, mga kawerpa, 3,100 lang po yung 4 na yan. No? Okay, so, well, that's it for today. Pasensya na kayo, ha? Nag-extend po kami. Maraming salamat po sa inyong lahat. No? I hope you learned from us. Thank you very much. Mga kawerpa, God bless you all. Stay safe. Thank you.